Hello and welcome to my channel. I am Sam Augustine. Please, if you are new here, kindly subscribe to my channel, and you have been watching my videos and you're not yet subscribed, please kindly subscribe for us to build the mathematics community. Thanks to Richard Owusu, a student from the University of Ghana, Legon, for requesting for this lesson. Now, in this lesson, I'm going to show that the series summation n equal to 1 up to infinity of 1 divided by n times n plus 1 is convergent, and find its sum. Now, to do this, we will use a simple condition from test of convergence. Now, please kindly subscribe, like the videos, share, and leave your comments. So let's see the condition. A series of summation a sub n is convergent if its sequence of partial sum Sn converges. That is, if the limit of S sub n as n approaches infinity equal to S for some real number S. So now, the condition says that if its partial sum converges, then it means that the series will converge. So let's find the partial sum of this series. Now, if we let an equals 1 divided by n plus 1 times n, then let's find its partial sum. Okay, so for the partial sum, let's say that you have ai equals 1 divided by I into I plus 1. I just want to change the a and the n to I. Okay, let's see. This is the same as a divided by I plus b divided by I plus 1. That is, the denominator is linear. We have linear factors, so that's how we decompose it into partial fractions. So here we have 1 divided by I times I plus 1 is equal to a times I plus 1 plus b times I, all divided by I times I plus 1. And since the denominators are equal, we equate the numerators. 1 equals a times I plus 1 plus b times I. Now, if I is equal to 0, we have 1 equal to a. If I is 0, 0 times b is 0, 0 plus 1 is 0, 1 times a will give us a. Now, if I equals negative 1, negative 1 plus 1 will be 0, so a will be 0. B times negative 1 will be negative b. So you have 1 equal to negative b and b will equal to negative 1. So this implies that we have this to be equal to 1 on I minus 1 on I plus 1. That is, a is 1 and b is negative. So that's what we have. So it means that the partial sum Sn is equal to 1 divided by n minus 1 divided by n plus 1. Now let's find S1, S2, S3, and so on. So if we take S1, we have 1 divided by 1 minus 1 divided by 2, which is the same as 1 minus 1 on 2. If we take S2, we have 1 on 2 minus 1 on 3. If we take S3, we have 1 on 4 minus 1 on 3 minus 1 on 4. So we are saying that if its sequence of partial sum, so let's form the sequence, that is S1 plus S2 plus S3 plus dot dot dot. So our S1 is 1 minus 1 divided by 2 plus 1 on 2 minus 1 on 3 plus 1 on 3 minus 1 on 4 plus this will go up to 1 on n minus 1 on n plus 1. So we see that if we are to add this, negative 1 on 2 will cancel positive 1 on 2. Negative 1 on 3 will cancel positive 1 on 3. It will go and go and go, and negative 1 on n will cancel positive 1 on n. That is what will happen. You see that the terms will cancel out. So here you will get negative 1 on n, that will cancel this negative 1 on n. And you'll be left with Sn equal to 1 minus 1 on n plus 1. Very, very simple as that. So this is our Sn. And now we can say that this is equal to n plus 1 minus 1 all divided by n, which is equal to it's divided by n plus 1, which is equal to n divided by n plus 1, which is equal to our Sn. So we can find the limits of Sn. So here you have Sn equals n on n plus 1. So the limits as n approaches infinity of Sn is equal to the limits as n approaches infinity of, we can put this one there or we can put this one there, any of them. So we can take n divided by n plus 1. Kindly subscribe to my channel, leave your comments, share the videos, and also like my videos. So here we just divide through by n, that will give us the limits as n approaches infinity, n divided by n all on n divided by n plus 1 on n. Very, very simple as that. So we have the limits as n approaches infinity, 1 divided by 1 plus 1 on n. And as n approaches infinity, very, very simple as that, we're going to have 1 divided by 1 plus 0, which is equal to 1. So the series converges and its sum is 1. The series converges and its sum is equal to 1. Very, very simple as that. So the series converges, it converges, and its sum is 1. Very, very, very simple as that. Thank you for watching. Please kindly like, subscribe, share my videos, and leave your comments. Bye bye.